Alright, so the pandas series object represents a single column data, or a set of observations related to a single variable. It corresponds to the one-dimensional NumPy array structure. We'll assume that's clear, and we'll focus on exploring various methods and tools related to the pandas series. We will also try to explain how different programming techniques can help us in our analytical work. More precisely, the idea is to develop the habit to back up your data cleaning and data manipulation skills with analytical intuition. That said, let's first see the data we will be working with. It will be the location CSV. As we import it with the read CSV method, we will set the squeeze parameter equal to true. Moreover, the type function can confirm that our location data variable contains a series object. See? What an analyst would immediately do at this moment is to apply the describe method to this series. Thus, they can swiftly obtain some descriptive statistics about the data. In the first row, we can see that this method has counted 1,043 values, 296 of which are unique. Then top designates the most common value, while the penultimate row, its frequency. Therefore, in our case, the string location25 can be encountered 31 times. Finally, we can obtain information about the file name and the type of data stored in the object. The describe method provides a nice overview of our data, as this allows us to quickly infer that this dataset is not huge and contains a relatively large variety of values. 296 of the data points are unique. However, should a programmer use this data for further computations, they'd rather use other tools to obtain the separate values. Simply, the built-in len function can deliver the number of 1043 to us as well. At the end of the day, this is a series object. So it is rather intuitive to remember that it is its length that corresponds to the number of values contained in it. The second number, although cited as unique in the output of the describe method, intends to provide the number of unique values. That's why the relevant pandas method is called nunique. As you can see, it delivers an integer number we can directly use for further pre-processing or data analysis. Now, I'd like to ask you to pay a little extra attention, since what I'm about to share can seem a little confusing at first. It is about how pandas developers have named a few methods similar in their functionality. There's also a method called unique, and when applied, it will deliver an array containing all 296 unique values in an array. Although our dataset contains perhaps quite a few unique values, we can still scroll up and down to observe the available values. What is important to remember is that this method delivers the values in the order they have appeared in the dataset. Nevertheless, the relevant output can still be very useful if you would like to check whether a certain value has been stored within the data. Last but not least, please don't forget to place the parenthesis at the end when using the nunique and unique methods. If you skip doing that, you will obtain a strangely organized output that doesn't contain the desired information. In fact, the type function will indicate in this case that unique is the name of the method, which would serve as a reminder to go back into the cell and add a couple of parentheses to our code. See? We hope this video clarified how we can use programming tools such as the nunique and unique methods to set off our analytical work by providing general information about the data stored in a series object. See you in the next lecture, and thank you for watching.